Welcome to the first video of the complete car racing game creation series. Well, what we're going to do in this series was already explained in the previous video, so you can watch it if you haven't yet. Now, let's get straight to the point. In this video, the first thing we'll do is create a brand new empty project. You can name it whatever you like, and we won't need the starter content. Some of you might think that making a car game from an empty project would be more difficult. But the truth is, there's no real difference between choosing an empty project and Unreal Engine's built-in car project. If you want to build a complete, realistic car game, you'll need more than just the default Unreal car template. All right, after opening our new project, as you can see, it's completely empty. But don't worry, we'll make it much better as we go. So first, we'll prepare our project with everything we'll need for this series. We'll start by enabling a specific plugin. Go here and make sure to enable the plugin called Chaos Vehicle. After enabling it, we'll also turn on an option that many people overlook, but I find very important. Go to Project Settings, search for Substepping, enable it, and set its value between 4 and 8. This helps prevent physics errors and unwanted overlaps. I've already made a video explaining this in detail, so you can check it out later. Next, we'll organize our project a bit. We'll create a game base and a player controller and leave them aside for now since we'll need them later. If you don't know how to create them, just follow my steps and give them unique names. Good. Now it's time for the real work. Here's where we'll turn our car into a drivable vehicle inside Unreal Engine. For that, I've chosen 4 cars to work on, as you can see here. I really like their design and quality, and I'll leave their download links in the description. Next, we'll need Blender for this step, but don't worry. Even if you're not experienced with Blender, we won't be doing anything too complex. I'll guide you through every part, and you can also download it for free. It's small in size too. Once you've done that, we'll import the car you downloaded. If you've downloaded the latest version, as I mentioned, just drag your file here and click Import. Now, as you can see, the car is right in front of us. Before we make any adjustments, we'll need a special plugin for Blender that supports Unreal Engine. It's a free add-on, and you can download it from the link in the description. Its purpose is to automatically create a skeleton compatible with Unreal Engine. Just follow the installation method I'm showing on screen. After downloading the add-on, go to Edit Preferences. You'll see a long list of plugins, but that's not what we need. Click Install, then locate the file you downloaded. No need to unzip it. Just select it and click Install. Once that's done, here's a useful tip. Click this icon here, then go to Statistics. You'll now see this panel on the side. Basically, it shows you some properties of your model. To explain briefly, the higher the number of triangles, the worse your performance will be later. So make sure your car model doesn't exceed 600,000 triangles. Anything above that will hurt performance, especially when you have multiple cars in your scene. Now, let's move on to the main task, preparing the car in front of us. What we need to do is separate the car body from the wheels. But before we group anything, we must apply all existing transformations in the model. To do that, we'll enable another plugin, just like before, called Modified Tools. After enabling it, select any part of the car. Go to this section and click Apply All. In my case, as you can see, nothing appears, and this button doesn't show up at all. That's because this car already had all its transformations applied before I downloaded it. However, if your car still has unapplied modifications, the button will appear. Just click it. If some parts of the car didn't apply properly, just apply them manually. Next, we'll start grouping the car parts. If your car model already has the body separated from the wheels, you can skip this part. Let's begin with the wheels. Hold Shift and click on every part that makes up one wheel. Once you've selected them all, press Ctrl plus J to join them together. You can enable wireframe view from here to make sure you didn't accidentally include a part of the car body, or to check if you missed something. Now, repeat the same process for each wheel individually. Select every part of the wheel, make sure all transformations are applied, and then join them. If your wheels are already grouped, you can skip this step. I'll speed things up here since we're just repeating the same process. Once you're done, rename the wheels to avoid confusion later. Front right, front left, and rear left. After that, we'll group the car body together. You can do it the same way as before, but there's a better method. Select all 4 wheels, then press Ctrl plus I. This will select everything except the wheels. Now press Ctrl plus J to join them. That's it. The body is now combined and separated from the wheels, as you can see. Next, make sure the car is facing the plus X axis. This is very important. Otherwise, you'll face annoying issues later during development. If it's not aligned correctly, simply rotate it. After that, press A to select everything, then press Ctrl plus A, all transforms. And this step is crucial. Once we've done that, it's time to use the add-on we installed earlier. Press N to open the side panel, click this option, and you'll see a new window appear. Now, what we'll do is simple. Assign the car body to the vehicle base and each wheel to its correct slot. Be careful not to mix them up. After that, click Set Unit Scale. Now you might not notice it, but the car has become smaller, so we'll scale it up to the proper size. Here's a neat trick I use. Add a new cube, then switch to this side view and click this button for better visibility. What we need to do is lift the cube by about 1.5 grid squares. That's the average height of a car in Unreal Engine. Then press Ctrl plus I, followed by S to scale up the car. You can move it using G and then Z to move only along the Z axis, since we want it centered and scaled correctly starting from the red line upward to the right height. Make sure the car sits at the correct elevation. Once that's done, delete the cube we added and click Rig Vehicle here. With that, our car is now ready for export to Unreal Engine. Now let's move on to exporting the car. Go to File, then Export. Change the settings here to Face, and then click Export. Now we'll import the car into Unreal Engine. We won't change anything in the import settings, and here's what we get. But as you can see, the car was imported without its textures. There are 2 ways to solve this issue. The first way is to import the car directly into Unreal Engine before transferring it to Blender. This way, you'll get all the textures and materials included. After importing, delete all the static meshes, since what we really need are only the textures. Then, simply replace each material in the car with its matching material that we just imported. It's a bit of a tedious process, so I'll speed up the video here. That's the first method. As for the second one, it's based on importing only the car textures separately and then creating the materials ourselves. We'll rely on the names that come with the texture files and link them properly. Once done, we'll assign each material to its corresponding part. Now, I'll stick with the first method for now, so I'll delete everything else. Next, I'll quickly show you, once again, how to prepare another car for Unreal Engine, because this time there are a few different things, along with some new tips. So, I'll create a new Blender file, import the car here, lift it slightly, and rotate it to face the +X axis. Now here's what's different this time. You'll sometimes find that some parts of the car are merged together, which can make it difficult to separate the wheels. To fix this, switch to Edit mode from the top and click this icon. Now we have two options. 1. Press P. By loose parts. This separates all unconnected parts, but the downside is that it can split one wheel into several pieces, creating more work. 2. The second solution is better. Just select one wheel completely, press P, then choose Selected. This separates it cleanly. After that, do the same for all 4 wheels, following the same steps as before. Combine the wheels and car body separately and rig them in the end. I'll speed this part up since it's repetitive. Also, make sure that all the wheels are properly aligned along the X-axis. To rotate them around their center, follow these steps carefully. Don't forget to check the wheel rotation from this panel as well. Everything else is exactly as we did before. You can skip this part if you've already understood it. I'll just show 3 cars this time, and I'll be focusing mainly on this one for the explanation. You can later apply the same setup to the others. Now, at this point, the most important thing we need to adjust is the physics asset of the car. You'll see something similar to what's shown here. we're going to delete everything and recreate it properly. After deleting them, we'll see all the bones listed here on the side. We'll start with the wheels. In the Tools panel, change the primitive type to Sphere and click Add Bodies. As you can see, a collision shape has been created around the wheel. Good. We'll do the same for all 4 wheels. Next, for the root, change the primitive type to multi-convex hull. It looks fine for now, though we might tweak it later. For the moment, this setup is enough. In upcoming videos, we'll modify the car's front collider because when it crashes into a wall from the side, we don't want the car to stop completely. We want it to rotate slightly and continue moving. This will give a much better driving feel. But we'll handle that later. Now, let's move on to creating the blueprint for the car we'll be driving. This is different from creating a regular character blueprint. Go here, search for Vehicle Pawn, and select it. This is how it looks inside. We'll add the car mesh we prepared, and we'll also enable physics on it. I'll tweak the physics settings a bit as well. Then we'll add a spring arm and a camera, adjusting the camera position slightly, and that's all for now. Next, we'll create a chaos vehicle wheel blueprint, which is basically a description of the wheel's behavior, how much it slips, how stable it is, and other detailed settings we'll go over later. We'll make one for the front wheels and one for the rear wheels. For the front wheels, first change this setting to front. Then you'll see wheel radius and wheel width. These depend on your car's actual wheel size. To find the right values, go to your car in the world, switch the view to top and wireframe, zoom into the front wheels, and measure their width using the middle mouse button. That value is your wheel width. For wheel radius, measure the wheel's full height and divide it by 2, since we're working with radius. Scroll down and enable Affected by Steering, then set the value to 60. That's it for the front wheels. For the rear wheels, change the setting to rear, and again, set the wheel radius and wheel width. They're usually the same as the front, but it's good to double check. Then enable these 3 options, especially Affected by Engine, which is crucial. Without it, the car won't move later. Once done, we need to assign these settings to our main car. Go to Vehicle Movement, Wheel Setup, and create 4 entries, 1 for each wheel. Expand each one and make sure the bone names match exactly with the ones in the skeleton, and assign the correct wheel class for each. Important note, the order of the wheels must match the skeleton's order exactly. Don't mix them up. Now, we're almost done. Scroll down to find Engine Setup. This is where we define the car's acceleration curve, top speed, and other driving characteristics. The most important ones are max torque. How much force is applied to the car over time, essentially the car's power. Max RPM, the maximum revolutions per minute, determining the car's top speed. If you're unsure about the right numbers, you can look up real sports car specs online. For now, I'll set max torque equals 440 and max RPM equals 5,500. Next is the torque curve. which defines how the car's power behaves over time. To make it simple, most cars have a curve that rises and then falls. That's physics and math for you. Create a new curve. Add two keys, both starting from 0.5. Then, set the second key to 5,500, matching our max RPM. To view both points, press Ctrl+A, and then click this icon above. Now just shape the curve so it rises and then falls. The highest point should be around 1.2. Your curve should look something like this. And that's it. All the setup for our car is done. If we test it now, it should work. But there's one small problem. We haven't configured the input controls yet. So let's quickly fix that. Create a new folder, and inside it, make 6 inputs. Steering, throttle, brake, handbrake, camera up, down, camera side. Start with the brake input, set it to axis 1D. Do the same for throttle, camera up, down, camera side, and steering input. After that, create a mapping context. Add all the inputs we just made and assign their keys. For car steering, it's a bit different. For the A key, add a modifier of type negate. Camera up, down, use mouse Y. For camera side, use mouse X. Now that's done, go to the player controller we created earlier. In the event begin play, add the mapping context we just made. Then, it's time to link all the inputs together. We'll first access some settings from the vehicle movement component. Create a cast from the vehicle component and rename it vehicle component for short. We'll be using it often later. Next, create a function called setUpMovement. From the vehicle component, drag out set throttle input and connect it to the throttle input action we made earlier. Do the same for set steering input. From the spring arm, add world rotation and add local rotation, connecting them to the Z and Y axes respectively. Then, bring in the camera inputs as well. Quick note, this current camera movement setup is just a basic version, not professional. Later, we'll completely overhaul it to make it smoother and more realistic. Next, we'll handle the brake input and handbrake input separately in the graph. Nothing special here. Just connect the buttons to set brake input and set handbrake input. Oh, right. I forgot to adjust the settings for that input. Let's fix it quickly. And now, everything for the car setup is ready. Just one last thing. In the game mode we created, assign the car pawn and player controller. Then set this game mode in the world settings. Now let's test it. Alright, what's happening makes sense. I forgot to adjust a few things. First, in the spring arm, enable camera lag and tweak some settings. This is important. Then, add the function we made earlier to the event tick. I'll also move the camera slightly to prevent it from clipping into the car. And add a small check here to avoid future issues. Now, as you can see, the car is working perfectly, and the camera movement is decent enough for now. There's still a lot missing, but it's a great start. Also, as you can see, the wheels aren't rotating yet, so that'll be the last thing we fix in this video. We'll simply add an animation blueprint for it. Go to the mesh, create a new anim blueprint, and in class settings, change the parent class. Then, connect the node mesh space reference pose to the output pose. That's it. Let's test one final time. As you can see, the wheels are rotating properly and everything runs smoothly. We'll end the video here, but this series will continue. So don't forget to subscribe to the channel so you won't miss what's next. See you in the next episode, and thanks for watching.